Hello students, in this video we are going to discuss about the Lewis acids and bases. As the concept of acids and bases, we have already discussed about the Arrhenius concept and the Bronsted-Lowry concept in the previous video. In this video, we are going to discuss about the Lewis concepts of acids and bases. Lewis concepts of acids and bases. G. N. Lewis in 1923 defined acids and the bases in this way. Acids are the substances that accept an electron pair and the bases are the substance that donates an electron pair. So these acids which can accept an electron pair are called as Lewis acid and the bases which donates the electron pair are called as Lewis bases. It can be clear from this general representation which is given here. In this, the A1 is an acid that is actually deficient of electron, but B is a act as Lewis base because it is electron rich presence of the lone pair here. So the substance that is actually donating the electron pair, that is the B is donating the electron pair to the A, therefore the B act as a Lewis base, and the A, because it is electron deficient, it is accepting the electron pair from the B, therefore A is called as a Lewis acid. So it results in the formation of a bond between the A and B. So here in this general representation, the electron rich is the B1 and the electron deficient is the A part. So the transfer of electron takes place from B to A. That means one is donating, the other one is accepting. So the donor is the Lewis base and the acceptor is the Lewis acid. So Lewis acid is a substance that accepts the electron pair and Lewis base is the substance that donates the electron pair. So here there is a donation and acceptation of the lone pair, that is the electron pair. Let us take one more example, that is the formation of hydronium ion is an excellent example of Lewis acids and bases, because the water that is having a lone pair, that you can see it have two lone pairs. So this lone pair, from this one lone pair, it can easily donate to H positive. Look at here, in this the water is having the lone pair because we can say that the water is electron rich and H positive is deficient of electron. Therefore, H positive is called as electron deficient. So the electron rich one is donating the electron to the electron deficient one. So here, which one is the donor here? Water is the donor of electron pair, therefore it acts as a Lewis base, and the electron pair is accepted by the acid, therefore acid act as a, here the H positive act as a Lewis acid. So like this there is a formation of a hydronium ion, that is we can write it this one as H3O plus, that is hydronium ion. So here there is also we can say that donation of electron pair and acceptation of electron pair. That means this combination is Lewis acid base combination. The next example here, the electron deficient one is the AlCl3 that acts as a Lewis acid, and Cl negative, that is electron rich, because you can see here lone pairs are present on Cl negative, but here the central atom is aluminium, that is electron deficient, because here the octet is not complete. As we have learned, this is the limitation of the Lewis structure. So AlCl3 is actually the electron deficient species because the central atom aluminium is not satisfied because the octet is not complete. So in this case, we can say that in order to stabilize, it accepts a lone pair from the Cl negative. Therefore, here there is a donation of electron from Cl negative to AlCl3. So here, which one is the donor here? Cl negative is the donor of electron pair. Therefore, that acts as a Lewis base, and AlCl3 is accepting the lone pair. Therefore, it is act as a Lewis acid, and this combination is result in the formation of bonding between these. So that is the example AlCl3 and Cl minus. Next example, that is the example between NH3 and BF3. Here you can see that ammonia have one lone pair. That means this is electron rich species, but BF3 is electron deficient because the central atom B is electron deficient because the octet is not complete. So in that case, the BF3 require a lone pair in order to stabilize, and this is done by the donation of electron from the NH3 to BF3. So that is here, the donor of electron is here, that is NH3 is donating the electron to the BF3. So here the donor of electron pair is the NH3 that acts as a Lewis base, and the acceptor is the BF3 which acts as a Lewis acid. So this results in the formation of a bond between them. So here one more example we will be taking, that is OH negative plus BH3. Here also we can see this is a negatively charged, that means the electron rich, and this one is a neutral molecule but electron deficient. Therefore it acts as a Lewis acid, that is an electron acceptor, and OH negative is the electron donor. So here also there is a formation of bond between them. So when we do a comparative study here, we can say that the Lewis bases and Lewis acid, which can also be called as a nucleophile and electrophile respectively. That means Lewis bases can also be called as nucleophile, and the Lewis acid can also be called as electrophile. Here the phile words means loving. That means nucleophile means nucleus loving. Nucleus loving means nucleus is positively charged. That means it is loving to positive charge. So someone is loving to positive charge means it must be negatively charged or the electron rich. That means the Lewis bases are electron rich, or we can say they have negative charges. Therefore they can easily donate the lone pair. And electrophile, phile word means loving. Electrophile means they are electron loving. Electron loving means they are loving to negative charges. So that means they must be positively charged, or we can say they must be electron deficient. That's why they love the negative charges. That is electrophile, electron loving. So these can be, say that a nucleophile is an atom or a molecule that can donate electron pairs. An electrophile is an atom or molecule that can accept an electron pair. That is nothing but we have defined the Lewis bases and Lewis acid respectively. Either they are negatively charged or neutrally charged. That means they are electron rich species. Lewis bases or the nucleophiles are the electron rich species. That means they are either negative charged or neutral. But when they are neutral, they must have some lone pair with it, like water. H2O is act as a Lewis base because there is a lone pair on it. Similarly, ammonia NH3 is act as a Lewis base because it have lone pair on the nitrogen. So that means the species that can act as Lewis bases if they are negatively charged, like OH negative is negatively charged, Cl negative is negatively charged, and some neutral molecules like water, ammonia that can act as the Lewis bases because they have lone pair on it. So such species are the Lewis bases. But in the case of electrophile, we can say that they are either positively charged or neutral charged. Like positively charged like H plus. H plus is electron deficient, that's why it have positive charge. And the neutral molecule like AlCl3, BF3, these are the neutral molecules, but they are electron deficient molecules, therefore they act as a Lewis acid. So these are the comparative studies of Lewis acid and Lewis bases, which are also called as nucleophile and electrophile. But in organic chemistry, we'll be using this word much more than the Lewis acid and bases, that is electrophile and nucleophile. We are mostly using this word in the organic chemistry. Now let us see some examples of Lewis acids, that is the electron pair acceptor, that is positively charged H positive, BF3 that is a neutral but electron deficient Ag plus SO3. These are the some examples of Lewis acid. As we have already discussed, Lewis acids are positively charged or electron deficient neutral species. But the Lewis bases, that is electron pair donor, there are usually negatively charged like Cl negative, OH negative, or the neutral species that having the lone pair, that is water and ammonia. So these are the some quite common examples of Lewis acids and Lewis bases. So this is all we have discussed, that is the acid base concept, which is called as Lewis acids and bases. So the next details will be discussed in the next videos. So this is all about this video. Have a nice day.